Alright, ladies and gents, welcome back. In today's video I'm doing something a little bit different from what my recent videos have been, which is that I'm talking about my eGPU that I've recently started back up again. Now, this project has been quite a few years in the making, and as you can see there is some interesting stuff going on. Now, originally I had planned on doing basically an eGPU project with my laptop using what originally was a really slim 1030 GPU from NVIDIA, and this project was pretty much going really well until I had realized that it was still really ugly, took up a lot of space, and I had to plug in a ton of wires, and it was basically just a jumbled wiring mess, and there was really no way for me to keep things consistent, so I decided to see if there's some way I can stuff that 1030 inside of the laptop. Now, this for the most part went okay, as I was able to get the card into the machine, but the issue was that I ran into problems with cooling, and ultimately I ran out of space as well for mounting all the various components, which again led me to believe that I had to look at alternate cooling solutions. Now, I spent quite a few years kind of hunting down various kind of cooling fluids, all kinds of stuff, even looking at things like hexane for cooling down the machine, basically without even running any kind of a pump, or at least maybe using a micropump to pump the fluids around so that it would get a decent amount of cooling. However, what I noticed is that unfortunately hexane is something that is quite flammable, and the pressures in the system tend to rise quite a bit, which means that really there are no cheap fittings that you can use in that particular instance, which essentially means that I would have to be using potentially copper tubing that is soldered in all kinds of places, and that is just too much of a time and money expense at that point to get a system like that set up. So I decided that the next best thing was to look at liquid cooling, as it can potentially save quite a fair bit of space versus air cooling, where I would need a massive heatsink. Now, it took me quite a while to figure out any kind of a way that I could have this system work inside, and had I stuck with a 1030 or 1050 as I later went to, where these cards were relatively slim compared to what I'm running now, which is a 2060 Mini. And unfortunately I realized that even with those cards, there's simply not that much room that I have to work with in terms of mounting radiators. And with those cards, even with liquid cooling, I was planning on using essentially 60mm radiators, meaning that they're 60 millimeters long. Again, not particularly big, and I would essentially use 3 of them in series. And at that point, that would be the cooling solution, using essentially MOSFET fans on them to move air around. And so they'd have 2 MOSFET fans on them in a push-pull configuration, with some basically sticking out the bottom of the case. Now, what I came to realize is that even at that sort of amount of cooling, it would not be sufficient for these cards basically to be able to maintain any sort of a reasonable FPS. So I came to the conclusion that the radiator is going to have to be external, and since I was basically at that point kind of hitting the limits of what the 1050 Ti could do, I decided that the next best thing was to purchase a more modern card. And as you can see now, we have the 2060 Mini in here, but that required a different cooling solution that would then still fit within the confines of this laptop, where I realistically have only about 14 millimeters of headroom to work with, which is to say that's not a whole lot, and that means that only a single slot cooler, or even less than that, would suffice. Now, the conclusion I ended up coming to is that there was no cooler that I could use that would let me do this. I've looked at some Thermaltake solutions from way back when, where they had a really tiny, really thin cooler that potentially could have worked. Unfortunately, these units are now almost impossible to come by. I've searched high and low and wasn't able to come up with anything. So the next best thing was to make my own cooler, which, as you can see, is right here. Now, I'm not going to divulge too much of the technical details on this, or how this came to be, but basically I'm using a custom cooler with custom mounting that is now using internal copper piping with basically a 3-channel design that loops from the pump all the way through the cooler and then back into a radiator There's not going to be any kind of an external res. I will be using the Alpha Cool radiator in the back essentially as a reservoir, being able to top it off and so on and so forth, which just means that it's a little bit inconvenient to refill the loop when I need to. However, the end result is that it's a very self-contained system, and in the next update to this, once I have the pump in here and I've looped everything through, making sure there's not enough kind of air in the system, meaning that I'm not getting bubbles everywhere, I will be able to do some actual testing of this quote-unquote eGPU, but now it will be sitting pretty much entirely inside the laptop. Now, unfortunately, even with this super low overhead solution, this is a very compact cooler, but it still doesn't give me quite enough room within the laptop, which means that in all likelihood, I'm going to need to introduce some kind of a 3D printed spacer for this to basically stay the way that it is right now, so that I don't have to basically have parts sticking out of the machine. So I didn't really quite realize my goal of making it entirely internal, but then with the external rad, it was never going to be fully internal anyway at this point. So with that said, you know, this is one of the most compact liquid cooling systems that I've come across for this kind of GPU. And I think despite the fact that there's not that much surface area with the Alpha Cool radiator that I'm using, which is a Penta, meaning that it is able to mount 8 fans, 4 across and then 4 in the back. So it will basically be using that sort of config. Now in my particular case, I think what I'm going to do is just have 4 fans on the back, and I'll see if that gives me enough room to play with here. I'm not planning on overclocking this card anyway, since it is going to be CPU bottlenecked anyway, as well as being PCIe bottlenecked, as I only have a ×4 connection on this laptop that I'm able to utilize. Now it will be running on an external screen, so that I'm not utilizing any more kind of bandwidth on the PCIe side of things, but I'm hoping that I will be able to get pretty decent results with this card. This particular version is a 6GB card, and even though I had plans originally to salvage some memory chips from another variant of this GPU to make it an 8GB card, unfortunately I don't think that there's a BIOS that is going to allow me to do this, and that also means that I'm effectively kind of SOL in terms of getting this card a little bit more VRAM, as 8GB is of course sort of the recommended spec nowadays at the bottom end for most cards. But with that said, this is primarily made to play Battlefield 4, you know, the likes of CSGO, StarCraft 2, so I'm pretty sure that it is more than enough to play those games at decent frame rates on a 1080p display. This is the primary purpose of what this machine is built for. It is essentially going to be a mini LAN computer for me, and as such, this should do just fine for those purposes. And again, it's just a project that's been something I wanted to do for quite some time at this point. Now, hopefully in the next video, I'll give you guys a bit more of an update. Again, I don't want to kind of go into too many other technical specifications of what it is that I've done and what I didn't do. However, once we cross the bridge of this thing being more or less set up and actually have it up and running, we should be on our way in terms of seeing what kind of performance this will result in getting me. Now, I think that the next sort of video will be just to see if I'm able to get any kind of a signal output and if there's going to be enough cooling for the GPU. So I'm going to see if I can just run it on its own, connected to my currently main PC, and just take a look at the thermals, and hopefully we'll have some decent results at that point. So stick around, check out the next video in the series. Until then, it's been Crazy Welder.